In this lesson, we'll be graphing linear inequalities. This is basically graphing lines, but with inequalities instead of equations. So there's going to be a little bit of extra work involved. We're going to start off with a very, very basic example. Y equals 2x plus 1. Now you should recognize this as being slope-intercept form. We have a slope of 2 and we have a y-intercept of 1. Now this is a regular equation, and if we were to graph this, we would start at the y-intercept of 1 and use the slope of 2, and we'll take a look at that. Now for an equation, we start at the 1 and then we would go up 2 spaces and 1 over for the slope, and we would connect our lines, our dots, and we would have a line. That was graphing a linear equation. Well, it's going to be a little different in this lesson because we're going to deal with inequalities instead of equations. Let's take a look at what that will seem like. Now we're going to take a look at how to graph an inequality and how it's different from the equation. Now this inequality is y is less than or equal to 1/3 x minus 1. So clearly this is slope-intercept form again, but the inequality will create some differences. But graphing is going to start the same way, with the y-intercept of -1. With the slope of 1 over 3, that means we'll go up 1 and over 3. And we'll connect the dots and get our line. On an equation, that would mean, hey, we're done. But this is an inequality, so we're going to have another step. This particular step is to focus on the y is less than or equal to portion. Well, what is y less than or equal to? Well, it's less than or equal to 1/3 x minus 1, which is our nice little line. So we have to ask ourselves, where is y going to be smaller than the line? Well, if we go back to the beginning, when we first learned how to graph, we learned that the top of the y-axis was positive y, and the bottom was negative y. Well, negatives are always smaller than positives, so where is y going to be smaller? And the answer is on the bottom. So because y is less than the line, we're actually going to shade in the area of the graph underneath our line. And our answer is the line and all the space below it. It can only be represented graphically. Now for this example, we'll be graphing y is greater than 3x minus 1. Now the first thing I want you to notice is that there is no equal sign here. That's important, and that'll come in when we actually try to graph our line. But let's start where we always start, with a y-intercept of -1, and then we have a slope of 3. It's 1, 2, 3 up, and 1 over. And what I'll do is, instead of graphing a line, because it doesn't say equal, what I'm actually going to do is a dotted line. Dotted or dashed, whatever you want to call it. Because the answer to this problem does not include the line, because it doesn't say equal anywhere in this problem. Now we've got to focus on the y is greater than part. And we have to ask ourselves, just the same way we did on the last example, where is y going to be bigger, on the top or the bottom? And as usual, it's pretty obvious, y is always bigger when it's positive, so our answer will be the top of the line. Now if there's any question about the top of the line or the bottom of the line in your problem, you can actually test your theory of what side you should shade by doing a test point. In this problem, it's pretty clear that the line is below the origin. So we could actually use the origin itself. Remember, the origin is the point 0, 0. And you could actually use the origin to plug in and see if it's a true statement. So we plug in a 0 for y greater than 3 times 0 minus 1. Well, 3 times 0 is 0. So we'd get 0 is greater than 0 minus 1. And then we'd get 0 is greater than -1, which I'm pretty sure is true, which means we shaded the right portion of the graph. Now, you can always do a test point like that if you'd like, but it should be pretty easy to tell just from the top or the bottom of the graph based on the greater than or less than. Now, for my last example in this lesson, I'd like to talk about what to do when the inequality is written in standard form instead of slope-intercept form. Well, there's a couple different ways to deal with this problem, but the simplest way is to change it to slope-intercept form. Since so much of our shading depends on the inequality being in terms of y, we probably should do that as a first step. So we'll go ahead and minus 2x from both sides. And we'll get 3y is less than 6 minus 2x. And then we'll have to divide everything by 3 to get y by itself. And we get y is less than 2 minus 2 over 3x. And if you'd really like to put it in perfect slope-intercept form, we could rearrange this and write negative 2/3 x plus 2. Now this example clearly looks like the other ones we've already done, and we know how to proceed from here. So anytime that they give the inequality in standard form, you're more than welcome to change it to slope-intercept form, and then you can clearly see the inequality portion and know that you'll be shading the bottom half of the graph.